I'm just waiting for a couple of people to join via their audio so that they can hear us. Okay. Good morning, everyone, and good afternoon if you're joining from anywhere outside UK, from Africa or Asia. Right, so today is our first impact forum for this particular cohort, which has been funded in 2022. And thank you everyone for sending your presentations. So the idea of this impact forum, as you all know, is that we would be playing your 3 minutes sort of video to the panel members. And I would like you to introduce the panel members as well in a minute. And they will be giving you feedback on the basis of the potential impact that can be delivered through this project. So basically, we don't want to wait towards the end of the project. This is almost like a mid review of the project, and hopefully you can take up some of the suggestions to extend the impact of your project. Yeah, so I would welcome our 3 panel members here. On my screen I have first Peter Allen. So hi Peter, and Peter is also our steering committee chair in SFN since I think the beginning, or Peter has been involved in SFN since beginning in 2017 and has been chairing SFN 2.0 since 2020. So thank you, Peter, for being here. Peter has a good background in remote sensing space technologies, and he will be providing you some feedback on that. And then we have Dr. Jens Jensen, whom many of you know. He's our SFN data science champion, working in SDFC RAL space, and he will be providing feedback to 3 to 4 of the projects. And then finally, we have Dr. Rachel Watt, and she is an expert in food safety, but also in variety of other things that she does as a consultant in Exponent. And she would be providing feedback for 3 of the projects for us. So thank you, Rachel, thank you, Peter, thank you, Jens, for agreeing to be panel members for Impact Forum. Okay, now moving to the first project. I think it's you, Himi. It's your project, and it's an AI key platform development, and we will be playing the pre-recorded video for this, and then following the pre-recorded video, there would be 7 to 8 minutes sort of discussion on the feedback, and the panel member to initiate the discussion would be Rachel for this one, and others can join if they have questions. This is an open discussion, so if you have comments or suggestions and we still run out of time, so please use chat function and input your suggestions and comments. So that would be super helpful. So yes, Cindy, over to you. Kindly play the presentation.
Thank you for inviting us to share the progress of our project, AIK Platform Preservation and Visualization of African Indigenous Knowledge for Resilient Food System 2.0. The project is implemented by Brunel University London and the Open University in collaboration with Mami Foundation and Jamje Agricultural Company in Sierra Leone. Indigenous knowledge is predominantly tacit. It is traditional and is passed from a generation to the other through word of mouth. Indigenous knowledge is dynamic and is continually influenced by local creativity, experimentation, and contact with external systems. In Africa, about 80% of the citizens rely on indigenous knowledge for food production. However, this important knowledge is at risk of extinction due to the increase in activities of multinational companies, small to medium-scale commercial farming in Africa, land grabbing by political elites, and rural migration of young people. This could put significant stress on food product security across Africa in the long term. Further, because indigenous knowledge is oral, it poses significant challenges for documentation, preservation, and sharing. There is also a notable disconnection between indigenous knowledge, scientific, and modern food production practices. Our research draws on data-driven and knowledge management systems to capture, store, and preserve indigenous knowledge for our research, education, policy decision-making. The goal is to promote inclusive agriculture and sustainable
I've lost sound here.
nutritious
Yeah, me too.
preservation
Can
and
you hear me?
consumption across Africa through the learning from indigenous farmers as well as farmers learning from each other. To address the research questions, we adopt citizen science and data science approaches. Both draw on the SDSC capabilities and skills. Our citizen science approach reinforces the need to research with citizens or farmers instead of researching on them. It operates at three levels: participatory photo and video elicitation, where farmers are given digital records to document their everyday farming and food consumption practices. Data collected include photos, videos are inputted into Zooniverse project to allow citizens to analyze and interpret the data as novice scientists. The third level includes the co-designing and demonstration of the AIK management system. The data science approach focuses largely on the computational processes of the data, including data visualization, API access, and promoting fair data principles. The next four slides shows examples of high-fidelity prototype pages of the proposed platform. This is the home page with map visualization as well as links to other different pages in the system. The landing page for the dataset where users can search different types of datasets. Landing page for the educational resources for anyone who wants to learn about African indigenous knowledge, including farmers, schools, and universities. The data analytics dashboard, which provide insights into indigenous knowledge, indigenous farming practices across Africa, which could be used by policy, research, and organizations working directly with farmers. In the long term, this project has the potential to promote learning between farmers to farmers and policymakers and research communities. It has the potential to bridge the gap between indigenous and scientific knowledge to better promote the integration of local and traditional knowledge into policy and strategic plans to improve farming practices, enhance food security, and reduce environmental impact. In the short term, we have already presented this work in the International Association for Media and Communication Research conference in July. We've also been invited by the University of Amsterdam to present our work on platform for participatory citizen science in Africa. We've recently been invited to present our work in the Institute for African Development Seminar Series in Cornell University, the US, on digital innovation in Africa indigenous knowledge. For the next steps, we plan to implement the design of the prototype to at least get a minimum viable product as proof of concept, organize demonstration workshop in Sierra Leone, write at least 2 publications, explore additional funding. We've already submitted a related proposal to the UKRI Future Leadership Fellowship on Data-Driven Agriculture in Africa. Thank you for listening. We welcome questions.
Thanks, Himi and Sam team. Sam is unfortunately not able to join
Yeah,
today,
Sam is
but
here.
oh, Sam is here. Okay, great. Sorry, Sam. I just assumed that you are not joining
Okay.
today based on your last conversation. So yeah, thanks, Sam and Himi. Right, we have now some suggestions and questions from Rachel. Rachel, over to you.
Thank you. Oh yes, I'm off mute. After 3 years of doing this, you'd have thought we'd have worked out mute and not mute, wouldn't you, by now? What a lovely and interesting piece of work. I'm very excited to see this way of documenting and actually then disseminating that local knowledge. I had a couple of very practical questions, actually. I appreciate that part of the output would be papers, but what about education packages for secondary and tertiary vocational education? I know from doing some project work in Malawi with my church that part of the challenge within populations in country with a very rural agriculture is that the knowledge can be lost, as you're saying, and not only lost, but not held in a way that's accessible. So my two main questions were, what about language? So English, Creole, other languages, because you're going to be capturing this from people who may not have English as their first language. And then secondly, how are you going to disseminate it, yes, from farmer to farmer, but also embedding it into secondary and tertiary vocational education so that it's available not just in an academic paper for higher education, but at that more lower level of education that's more accessible to the next generation.
Okay, let me take this off. Then Emina can, chip in. Thank you so much for your questions, Rachel. So I think this project will have quite a number of thought around it, and that is why for now we have these two major components, the education part and the data-driven part, right? So the education aspect is going to actually, like you said, provide farmers to farmer, right? And there is a long-term plan because there's something that we've also discussed, extensively with Emina in terms of how it can be accessed by secondary education. People. So one of the ways we're trying to do it digitally is to, in the long term, when we have enough funding, is to sort of embed a mobile phone sort of SMS access, right? So where we have a text-based or digital sort of voice integration. So just a simple code. Let's say if it's searching for rice preservation, right? So you send that code, it automatically give you all the information you need. So that is one way. The second way, again, we plan to work with, that's why we're going to do the demonstration externally. We plan to work with the Ministry of Education as well in terms of promoting this indigenous knowledge. So there are probably ideas that may come up in terms of providing packages, either in other form, written format, other format. So it's a kind of a huge project, hopefully in the long term.
Yeah.
Yeah.
Yeah, it's a big project.
Yeah.
And that's really good that you're talking to the Minister for Education, because one of my questions was how to get this on the curriculum, how to get rural horticulture, agriculture into the curriculum so that it's valued, but also that you have that progression from historical, verbal, family knowledge being documented, which is what I've understood is the prime purpose of this project, is how can you gather it, document it, and then disseminate it. Yeah, is that right, Sam?
Yeah.
And I think, sorry to say that one of the things that we have, for example, the data that we have is actually like videos, interviews. So it's also like the narrative behind of people who like community members, farmers, women, children. So we have all this sort of narrative, and I think that's also the idea to just like build in others that have done some work already, if they would like to share it here. So when you put, I don't know, cassava, you could find cooking cassava, preserving cassava, like, so
Yeah.
you can actually learn from the practices on the field, and as well as people already, for example, producing lots of report and material if they would like to host it there. So you could actually access all that material that has been developed, but not necessarily hosted, and make it available for others. And I think that is also something that is getting very lost in rural like spaces where there is a lot of documentation, but not available to anybody else in a way.
And will that be also picking up oral to written, written to oral, so literacy doesn't become an issue necessarily?
Yeah, we do have that. So if you, I mean, when we finish, even with the fidelity ones, if you click on the text about cassava, we're going to sort of a more high image, you'll be able to get the local, because most of the videos that we have are actually in the local languages.
Yeah.
Right. So you can actually listen. Right. And those who want to read the text can also read the text.
That's really good. Yeah, a nice question from Ruben about translation, because I was just checking how many languages, and there's a lot.
It's a lot. I mean, so I think, yeah. So that, I mean, I think in fact, that is one of the reasons why this project has significantly delayed, because we want to build it on Python Django AI based, because in the long term, we want to have an inbuilt intelligence system in it that can help us with language translation. Right. So that is basically the purpose. In the long term, we want to do that. Then in the short term, again, we do have a research team in Africa who are actually helping us to translate some of this knowledge into English that we have currently.
And forgive the silly question now, because I'm a biochemist, I'm not a data scientist, but is there an opportunity, or am I going to blue sky, about having AI virtual translation that would be able to, instead of being relying on individuals of people, there are so many different languages that actually there's an opportunity to use some AI in helping with that translation? Or is that, we're creeping away, aren't we? But I know it's within the spirit of the STFC network activity.
Yeah, it is. I mean, it is. That is why like I said, we've delayed this project because we're really struggling to get someone to help us build it around the Python kind of platform, right? So there is a long-term plan for that. We're still exploring that. We're kind of using some form of AI based on natural language processing that will help us sort of interpret this, right? So there is a plan for that, but I mean, technology is not cheap.
Well, that's what I was thinking. It's not cheap. It's not easily available.
It's not easily available.
But a lot of people have a mobile phone in their hands, and the technology is not really fully leveraged, is it? That they have in their hands, especially the younger generation. They might not, they might not have shoes, but they've got a mobile phone, and they might not be literate, but they've got a mobile phone. And I find that really exciting, because it's an opportunity to get down to the the smallest of communities, with just one phone per community would give them wonderful access to information.
Yeah, absolutely. I mean, I agree with you on that. So we're also looking at the technology availability. So one of the research we did was looking at the social technical context, try to understand what sort of technologies are currently available and how can we tap into that to integrate as part of this project. So it's like, I mean, Emina said, we're building it step by step based on funding that we have. So we just want to thank STFC and the Food Network for giving us this sort of really opportunity to have it started, basically.
Yeah, I had one very small last question, but I think it's quite important, because I hear you about overlaying and imposing, might be a better word, industrial practices onto a pastoral rural landscape. I'm a farmer's daughter as well, which is why it's pronounced, and I was saying I've got kind of wellies in different positions, but it's understanding what would be useful for them so that they can make decisions when presented with these fertilizers, this pesticide versus this way of doing agriculture in their particular landscape. Is that going to be part of this, or is that going to be part of the bigger vision?
Yeah, it's going to be part of the bigger vision, because it's a small fund that we have. I mean, I can't understand your point there. right? Because what we've seen across, is moving across Africa is isolation of these, rural farmers, right? We see the penetration of these modern agricultural farmers, then also land grabbing is crippling in. So we're thinking about inclusive agriculture. That is why we're also working with the Ministry of Agriculture. They're also part of this project, right? To see how can we do kind of what we call inclusive agriculture. We are gender because majority of rural farmers are women.
Yes, yes.
Right? So how can we make them inclusive into the agricultural practices?
And integrating that animals, plant growing, integration of everything they've got to add value and layering it.
To add values,
supporting
exactly.
the soil
it is. There's a lot we can learn from traditional farmers in terms of even addressing issues around climate change and variability. Right. But those knowledge, like Emina said, they've not been communicated or either they've been ignored.
Yeah.
And
then they've got some best practice that isn't ignoring, as you say, all of that indigenous knowledge, which is why I love the title of the project, because it's knowledge that we will lose and they will lose. So exciting.
Thanks, Rachel. And if we do have time towards the end, we would welcome a little bit more wider discussions from all the participants, and I would throw in some of my thoughts as well. But in interest of time, let's move ahead with another project.
Sorry, Sonal, I was going to say I have some comments as well, but realizing we've run out of time, I'll try and communicate them by mail or something.
Yeah, mail or chat, feel free to use that because I'll
chat.
Okay, then go ahead, Jens. We can't keep you for long. Go ahead with your comment.
No, it's fine. Let's move on. I'll do it by mail or something. Sorry.
Okay, that's fine. But hopefully we'll have some time towards the end and we can pick that up. Okay, our next project is on blockchain. So blockchain-enabled cloud computing-based integrated carbon calculator. And I think we have our team here, Shushma and Dhaval. Both are involved in this project, and Jens would be the lead reviewer, for this project. Okay, Shushma and Dhaval, over to you.
This is a blockchain-based carbon footprint calculator project. It is a proof of concept project in collaboration with STFC Food Network to calculate CO2 specifically in beef supply chain process. To talk about challenge, the biggest challenge is around finding the exact calculation of carbon footprint starting from the farm to the retailer. This is because there is a gap in collecting data at each level and getting a verification done by each stakeholder. The idea of blockchain is to collect the data at each level and finally use the combined information for data analytics. This is important specifically now due to rise in global warming and impact on climate. There is a predicted loss of $23 trillion in global economic output and millions of lives if the net zero climate objectives are not achieved by 2050. The idea is to build one-of-a-kind sustainable and innovative applications to calculate the carbon footprint and make present beef industry sustainable and environmental conscious. The project plan is currently divided into two sections. First is the research part, in which we will collect and understand the various calculation methodology from international recognized database and national inventories. We'll check and refer all the articles and research papers on the internet. We'll also check database like DEFRA and IPCC, which are currently being evaluated for Tier 1 and Tier 2 emissions. In the second section, we'll be building a cloud computing integrated calculator, which will be based on blockchain technology. This will be provided as a freemium tool, and it will compute each stakeholder's net aggregated carbon footprint. It also offers suggestions, measures to reduce and substitute their conventional practices to mitigate emission. Talking about impact, it is cost effective, no requirement to purchase individual calculator, increase the value and confidence among the stakeholders. Customer will prefer eco-friendly food, which also enable retailers to charge more for premium quality products. It helps in ranking business according to their carbon footprints, and it assists in auditing supply chain and help the government and international organization in formulating policies. In future, we are expanding the user base to European countries, Latin America, and Asian markets. We strive to collect more information and emission data specific to various geographical areas, breeds, and climate conditions. Inclusions of non-cattle animals in our calculator app. and we'll be partnership with academics and agri consultants to develop new methodology and contribute to IPCC Tier 3 emission factor. Thank you. Hello everyone.
Thanks, Dhaval, and thanks, Sushma. And I know other panel members might have a question or two, so feel free to either use the chat box, or if we have some time, then we can pick it towards the end. Jens, over to you.
Right, thank you. So that was a very short presentation. I know we've talked about this before, but so I'm still curious about why you actually need to use a blockchain. I know you talked about using Ethereum, and Ethereum switched their consensus algorithm to being less computationally expensive, but it's kind of, as you know, many blockchains use very expensive, resource-intensive processes for establishing consensus. That was a question.
Thanks. Thanks, Jan. Actually, as mentioned earlier, we are using blockchain just so that we can trace the entire supply chain. So we want to make sure that every stakeholder in the supply chain, if they're making any changes, it is approved by others. Because right now what we are developing is a prototype where everybody has their own login and they can log in the data. But we want to make sure that if they're making any changes, because just for an example, if the feed type, the 4 major feed types according to IPCC, even if we change from one feed type to the other, the carbon emission changes by 25%. So maybe we just want to make sure that whatever data is entered in our prototype is authenticated. And if anybody is making any changes, once they're in the system, it should be approved by everyone in that, approved by all the stakeholders. Dhaval, do you want to add anything?
Yeah, I think just to add a little bit to that, I think the traceability of data across the network is one of the key factors why we are trialing the use of blockchain. And we discussed that we are looking at Ethereum for doing that, and Ethereum has a framework which allows us to trial these sort of things without, actually impacting the actual blockchain. So you can have a virtual sort of a blockchain to trial some of the proof of concept as we are planning in this particular project. Your question around the sort of balancing against the computational heaviness of using something like blockchain, I think we are quite conscious of that, and that's probably we would be looking into sort of measuring that, what is the cost effectiveness of a solution like this, and pro and cons of using something resource heavy blockchain as a solution for something like this. So the answer to your question is that we are conscious of that, and something which we would be sort of experimenting and noting down, and also bringing in as part of our research as well the pros and cons, especially around the resource heaviness of blockchain.
I know we'll be working on this in the coming months. So just for the record, blockchain provides 2 features. It provides irreversible logging, and it provides distributed ledger. And sometimes you need one and not the other, and there may be better ways of solving that. It is quite rare for a project to actually need both of those. So I think for now, it's fine for you to use Ethereum, because that's an existing package. You have looked at it, and it's there for you to trial. But if going forward, we should try and investigate alternative options. I think just because there are potentially better ways to integrate people's, like the origin authentication that you need.
Thank you.
So otherwise, in terms of impact, I think in general projects, so all of you should have a presentation like the one you give today, but one that's intended for the public. So you have something that we can put on YouTube for the food project and say, this is what we do, this is what this project does. And the presentation that you just showed is fine because for me, because I know a little bit about what you do, but we should probably try and work on one for your project that is a little more sort of targeted to the project, to the public.
Sure.
Yeah, could I just follow up on that? Because I've got a question, and I'll be asking this of almost everyone. So what's the incentive for the farmers to be doing this? And that's the sort of thing that could be put in the video that Jens is talking about. What's in it for me as an end user?
Actually, like as we mentioned, that as an end user, for example, if I'm a customer, I would love to buy something which is emitting less carbon, looking at the carbon, like the climate change. So our main, the main aim, we have come up with this idea because we feel that maybe a few years down the line, even the customers, they would be interested to know how much carbon has been emitted while they're purchasing any product. So this prototype will help the industry, like, okay, this is how we can make sure or how we can calculate the carbon emission in a product. Right. So we have just taken this as an example, but it can be used overall, like in any product, any type. So we want to develop and again, another thing is that beef supply chain, it is one of the supply chain where you have a lot of carbon emission to that. They're the major contributor. So we have targeted this area, but it can be used for any product. And this is how we feel that we would be contributing towards the society. As I said, yeah.
May I ask a small question? I completely echo what Peter was saying. I'm not clear as a potential end user, say I'm a farmer, what the benefit will be, but what the cost will be to me, because this will not be a nice to do. This will be mandated by their retailer customers, because as soon as eco-labeling starts, as soon as any regulatory demands start in terms of financial, either penalty or reward, depending on your carbon impact, and it's coming very, very soon, this will be a mandatory thing. So it's got to be affordable for, the crofter beef farmer almost, to minimize the impact and get accurate data. Otherwise, it will just be an arbitrary number, which will make no sense whatsoever to people. So I'm excited that a more accurate way of doing carbon calculation is going to be developed. That's very, very helpful, because at the moment there's averages of averages, which doesn't allow people to demonstrate where good practice is. But yeah, the cost, what is it going to cost me? I have a phone, I have an iPad, that's what I run my farm off. Can I do it with that? And not need a very large fee or license fee, and certainly not need anything more technologically complex than that to input information.
Oh, thanks for your question, Rachel. It's a very important point, like how much it will cost and how much they have. So the main reason we have applied for this project, and thanks to Sonal and STFC for funding it, is just that we want to develop a prototype. So it's not that just this calculator I have developed. I have already developed 3 calculators, and the projects were funded by ERDF, and we are working very closely with the Aura Center. So we are trying to use the public funding so that we can develop, because for a company called iParcel, they have a calculator where they are calculating the carbon emission for 1 mile delay. Like every time we are delivering the parcel to the customer, how much carbon we are emitting. So what I'm trying to say is that we are trying to use right now, we are trying to develop this prototype. We'll see, but definitely our aim is that we develop a system where the farmer doesn't have to pay more, because right now there are lots of carbon calculators available. It's not that there's no carbon calculator, but everybody have their own way of calculating carbon. Like even if you see that right now, what we are following for the farmer side is IPCC standard, which is like United Nations standard. And we're trying to maintain that. We're trying to stick to their standard. But again, there's one complex one easy one. So our target is that next month we are having a focus group where all the stakeholders, we are inviting all the stakeholders to get their feedback and see what are the things based on IPCC standard should be the part of the calculator. What are the information the farmers they can provide, and based on that we will be developing this prototype. But definitely yes, right now I would not make a comment on what will be the cost, like they will have to pay for the login, but at present this prototype definitely they don't have to. And we are also planning to apply for another funding, big funding. Once this is like, if we are if we are successful developing this prototype, we are planning to apply for another funding so that we can develop a complete system, at least for the beef farming.
Thank you. Thank you, Sushma. Thank you, Dhaval. Sorry.
May I have one more small comment?
Sure.
Farmers have to already supply an awful lot of information to DEFRA and various other government organisations to register their farms. I would just throw in a thought to consider combination of data collection with existing data provision that they have to mandatorily provide, and see how that would fit, so there is a one place to deliver all information for them, whether that's for registration or for declaration.
Sure. Thanks, Rachel.
Thanks, Rachel. I have some suggestions, but I will put it on the chat box. So Dhaval and Sushma, you can follow that up. And if we do have time towards the end, then maybe we can have an open discussion on that. Okay, so moving on with the next project on my list is Spotting the Rust from Dr. Melina Zampira. And our reviewer is Peter Allen for that. So Melina, over to you.
Hello, my name is Melina Zampira, and I will briefly introduce our project that is named Spotting the Rust. Its title literally states what we, RAL Space, NIAB and Scientific Remote Sensing are planning to do with this funded feasibility study. Wheat is a global commodity and its production is a key component underpinning worldwide food security. Our research plan combines static and aerial imagery that will be utilized to early detect yellow rust in wheat as a means to limit its spread and support targeted treatment that will eventually lead to a more sustainable use of resources. Furthermore, with our field and in-lab work, we aim to update existing model libraries to improve their accuracy. Nowadays, we have the appropriate scientific equipment, image analysis tools, and experience to be able to successfully conclude this study. To achieve our goals, we have planned to have two different but complementary experimental settings. The first group of measurements will involve static sampling of healthy and diseased wheat within a control environment, which will form the basis of our spectral libraries and will be our benchmark to the aerial surveys. For the latter ones, we will have multispectral and hyperspectral images taken from above with the use of drones, targeting wheat plots of different rust disease levels and statuses. So, we believe that by delivering a concise approach and scientifically sound findings, the proposed work will ignite the interest of stakeholders, researchers, and decision makers. We do have plans to create some impact through open days, outreach teams, and social media activities. We also have the ability to communicate our work through already built collaborations and networks. As this project has the potential to get into larger scales, different crops or plants and diseases, we also currently consider active funding calls from the UK Space Agency and BBSRC. Thank you.
Thanks, Melina. Peter, over to you.
Right. Thanks, Melina. This is looking very exciting work. My first comment is that at first sight, it looks like there's synergy with the AMMS project, which we'll be hearing about later on. So I just wondered, have you had any thoughts in that direction?
Yes. Indeed, we are going to support the AIMS project, but the scope is a little bit different.
Sure, yeah.
AIMS it tends to have data fusion between aerial and static, so the instrumentation is the same.
Yeah. Okay. Anyway, you've thought about it. That's all I'm really asking. What sort of products and services are you thinking of developing so that there are specific things for people to actually use?
Yeah, so we are aiming to develop a tool that will be able to identify areas that have a potential interest to have an advanced treatment with regards to yellow rust on wheat. So we will develop the identification and classification tool based on the imagery that we will get from the plots, and we are going to use also the libraries that we are going to develop through the in-lab measurements as well.
Okay, that's sounding very promising. And what thoughts have you had about how this might be commercialized? And I'm thinking about it not so much from the point of view of making lots of money, but just getting people to use it. If it's going to be taken up widely, it needs to be commercialized in some way, I would think.
Yes, yes. So the good thing with our system is that it's an affordable technology. It's not too expensive, a couple of thousands for each of the sensor. We do have the visible and the near infrared. Maybe the tool and the study will show that we don't need to have both of them. We can only have one. And the advance of this system is that it can be mounted on a static or on a moving platform, so the farmers can just buy. It's a commercially available off-the-shelf cameras. They can find the suppliers. There are multiple suppliers, and they can mount the system onto the tractor or to the drone. If they have a spraying drone, they can use that as well. They can have it as a static on top of a conveyor belt.
Okay, so I like this idea that the farmer would be using stuff that they might well have already. So I can see them getting more interested in using it, because rather than just saying, well, there's this completely new thing. Do we want to use it? I'm not sure it's really worth it. Yeah, I like that.
It's always challenging to get people to try new things.
Yes.
So we thought that maybe having a system that can be incorporated onto existing tools they have would be more a better idea.
Yeah. Okay, thank you.
I suppose you could do it as a consultancy as well. Like you could have a small company that rents out the drone to the farmers or does the scanning for them and returns the analysis to them.
Yes, yes, that's also an approach. Thank you, Jens. Thank you, Peter.
And I suppose with your work, you will find out which frequencies are give you the most information.
Yes, that's one of the aims of the in-lab measurements, to identify which wavelengths are of the most interest. And once we do that, in fact, we are planning to start imaging next week with NIEP. Once we do that, we also have the tunable multi-band sensor from the scientific remote sensing, and we will just pick the appropriate wavelengths based on the research we've done in the lab.
Right. And you will need to look at, so obviously you're looking at the rust, the wheat, and but out in the field you would have different climate conditions. Like it may be wet after it's been raining, or it may be cold, or it may be.
Yes, that is exactly why we chose to have both in lab and in the field measurements, to see the difference and to move from a control environment to the field which you don't have a control environment, and to see how the things are changing and how the tool can perform on both situations.
Okay.
Okay, thanks everyone. Thanks, Melina. And I'm really pleased to hear that you will be starting to do the imaging next week. So we'll have some more results, hopefully by the time we are presenting this in conference. Yeah.
Yes, hopefully. Yep.
Yeah.
We
Okay,
need some good weather.
Fingers crossed.
Fingers crossed. Yes, thank you.
Okay. Thanks. Okay, so moving ahead, next we have Aditya Parmar from University of Greenwich, and they would be presenting on exploring the feasibility of geographic indication marketing to improve pastoral livestock marketing in Kenya. So over to you, Cindy, and then I think Rachel is the lead reviewer for this one. Yeah, go ahead.
Hello everyone, my name is Aditya Parmar. I work at Natural Resources Institute of University of Greenwich. Our project title is Exploring the Feasibility of Geographical Indications to Improve Pastoral Livestock Marketing in Kenya. Our local partner in Kenya is Center for Research and Development in Drylands, and from STFC side, our co-investigator is Jen Jensen, who is an expert in data sciences. The food challenge which we are trying to address in this project is about understanding the marketing systems of livestock products, particularly meat products from Marsabit County to urban centers in Nairobi. The meat from Marsabit County is already known for its distinct characteristics such as better texture, taste, and aroma. This relates to the particular environment in which these livestock grow in that county and particular food they feed on in those pastoral systems. Objective of our project is to explore if geographical indication-based marketing systems can be applied to this particular value chain where meat from Marsabit County pastoral systems travels to the urban centers of Nairobi and sold at a premium price. Can this premium be transferred back to the pastoral community in form of a geographical indication? And for that, we need to have a proper track and tracing systems implemented. Our methodology currently relates to data gathering based from the key informants from public and private sectors and also from the pastoral community. Currently, we are doing surveys with the private abattoirs, policymakers, and some of the pastoral farmers who produce these particular goat and sheep meats. STFC capabilities which we want to use in our project is related to data sciences, particularly track and trace systems for those goats and sheep meats which travels from Marsabit to Nairobi. Current engagements with challenge owners which we have is the survey and the interviews which we are conducting with pastoral livestock keepers, also engagement with industry, particularly private abattoirs, and policymakers, including local and national associations. We want to understand what the exact policies are there in Kenya for such a marketing system where geographical indication is implemented on a meat products. This is first of its kind initiative in Kenya which we are trying to address. Our plans after this project is to have a model or a prototype trace and tracking system which is currently missing or absent in Kenyan livestock products.
Thanks, Aditya. So we have now Rachel to start the discussion. Rachel, over to you.
Thank you. Thank you for this. I think this will really add value to the Kenyan agricultural community. I didn't find any reference to looking at existing geographic indications. There's a well-established process and system in the EU to recognize GIs, not only coming from the EU, but from other countries. Are you going to include calibrating and building upon the learnings and the standards that are already there? And my kind of supplementary question was, are you then going to try and gather the data in such a way that that GI will be recognized by the EU as well, thereby extending the market?
Unfortunately, our local partners from Kenya could not join today. But yes, that's the idea that we want to look at, global geographical indication systems, and also what are the national, current national Kenyan, regulations and the policies regarding this. I mean, there is not much of geographical indications in Kenya right now, but I know there is some on coffee and tea. So there is some regulations, but not on the other food products like meat and, milk or some other products. But there is some geographical indication based or trademarks on coffee and tea, so which come from particular region. But I mean, I've realized that in most of the global south, or in the developing countries, the geographical indications is very weak. If you compare countries like India also, or there in whole of India, there are like maybe 3 geographical indication. If you compare with Italy, which has, I don't know, 800 maybe, or thousands. So it's, I think the marketing systems are more complex, and it's difficult to, what I was in Kenya last month, and we were doing some of the surveys and meetings together. So one of the most challenging aspect of it is the actually tracking, or proving that the product really comes from there. So that was the most, that's why our focus now is to look for technology or management practices where we can have this established value chains where we can say that genuinely this product comes from this region, and it is it can be proved.
So I could hear a risk in the project is that you might end up trying to create a geographical indication model where Kenya's regulatory system don't already have one. And I would recommend that you don't take the time to do that, but to perhaps take the EU requirements, of which there's great detailed guidance, and then also contact those who have a geographical indication already for a similar type of product in several EU countries, to learn from them, learn what they're measuring, and then see how you could replicate that in Kenya, but also to perhaps talk to the European Commission about fraud, because they are tracking and are identifying, if you were going to start from the beginning again, how would you have designed a geographic indication for this kind of product? And then take their learnings and build it into your track and trace model, because this is absolutely ripe for fraud. The minute you get meat off an animal, so as soon as you have meat off an animal and it's no longer recognizably meat, and there's one, as we all know, in the system right now that is massive, where there's been adulteration with rotten meat into the meat supply into the UK supermarkets. And that's not even with a GI, that's just meat. So as soon as it goes from being a leg of lamb into a lamb burger, you can lose it. So there will be lots of learnings, Aditya, that you could take that gives you an opportunity to build a superb model for Kenya. And also, this is meat. So I was also going to ask you, what about sheep and goats milk and dairy products? Not to do it now, but to think about that whilst you're collecting the data, because everything you capture on the animals could also be used for dairy products from those same animals and from that same land area. It might be that it's not a suitable land area for milk producing mammals, but why not?
So there is a milk value chain, but not for goat and sheep milk, but camel milk. We have another project which is funded by ATP. I don't know if you know about the African Knowledge Transfer Program, which is related to camel milk value chain from northern Kenya to Nairobi. So there we are trying to also implement some of those, trademarks and this regional.
Again, it's easy to lose identity. And there are all sorts of different schemes for it, and really challenge it, and almost from a catastrophic point of view, think about how people could break it whilst you're designing it. But take the learnings from that. That was my kind of challenge and risk to you, is don't invent something when there's something already very well established. And also look at what New Zealand do. They have some very good examples for their meat and dairy industries. And I'm sure the government contacts would be very happy to give you some time to share their learnings and build that into your feasibility and how you would structure those value chains and the kind of scrutiny that you would need to build into it, and then design your data collection model from worst case through to best case.
Thank you.
Help?
Yeah, I think that's very useful. Thanks a lot. Yes.
Pleasure.
I still think there are practical things about, like when Aditya and I talked earlier, that because they don't control the abattoir, so things could happen there that could mix up stuff and things. My thinking originally, which was whether you could just do DNA sequencing of the meat and compare, because the goats would have a different phenotype, sort of expressing genes and stuff. But that may be impossible.
No, I think that's a great idea, Jens, and I would suggest that for as not as a foundational, but an as well as, because first of all you have to get the old-fashioned paper trail right, and then you would use that as your monitoring mechanism, and finding a way of doing that that's a cheap and cheerful way that's accessible.
You can only sample products. You can't measure all of them probably.
Yeah, exactly. Then that's your monitoring step, where you're sampling to verify rather than your foundational evidence. Yeah. I'm a big fan of traceability.
Thanks, Rachel, and thanks, Aditya. I might have some insights from our work with FSA and abattoirs and farmers on track and trace. So we can share some of those insights. Like what is valuable for farmer might not be super valuable for the abattoirs to trace, and how do we bring those two together to make sure that we have end-to-end traceability. So there's a lot of discussions on the institutional logic and the value that can come across by sharing those data, and that has some regulatory implications as well in order to, like, what should DEFRA do and what should FSA do in terms of track and tracing. And I think it could be some of the learnings can be transferable in Kenya.
Okay, sure. Thank you. Thanks.
Super. Right, moving on to the next project. So we have now Vivat Wong, who has joined us from Thailand. Thank you, Vivat Wong, and his project is on corn yield prediction via integration of remote sensing, machine learning, and crop modeling. Very interesting. And the lead reviewer for this is Jens.
The title of this research study is Corn Yield Prediction via Integration of Remote Sensing, Machine Learning, and Crop Modeling. The challenge is to most accurately estimate the yield in tons per acre of sweet corn. The project timeline starts from September of last year until September of this year, covers 2 growing seasons. The first growing season is from December to March, and the second growing season is from April to July. So the method that we use is to first capture airborne multispectral images throughout the first growing season over 10 plots and generate NDVI at various stages of growth. Doing it in parallel, we input the dataset to the DSAT crop modeling software to predict yield. And on harvest day, we compare the predicted yield to the actual yield to see the results. Concurrently, we overlay a 2 meter by 2 meter grid on the 10 plots. The grids with varying NDVI levels in these plots are marked as sample grids. And then on harvest day, we locate the sample grids with varying NDVI values and weigh all the corn within the grid to get yield in grams per 4 square meters of this quote miniature plots for the machine learning process. In the second growing season, a test plot using different methods of soil preparation, planting, deployment of fertilizers, pesticides, herbicides is planned. And in order to compare the quality and the yield versus the traditional method. And on harvest day, the quality and yields of these two plots will be compared, and hopefully it will be a showcase to the growers. Hopefully that we will be able to convince the growers in this community and others to follow suit. So the next step is to integrate the crop modeling and machine learning to improve the prediction accuracy even better. And this research is expected to be expanded to accommodate other crops of Southeast Asia, namely rice, sugarcane, cassava, palm oil, and many more.
Thank you, Vivet Wong. And now we have Jens to follow up.
Okay, thank you. Interesting. So you will have a lot of parameters, I guess, because you have the weather and you have the temperature and you have the climate. I was about to say climate. You have the storms and lots of things coming in, and as well as the soil, the types of soil. You have the nutrients that you put into the soil. You have the pesticides. How do you make sure you get enough span of all those parameters in your data set?
I think those variables are the inputs to the DSAT problem modeling program. It takes care of all. It has a sort of a minimum data set to start with, but you can add all these other variables to it. But in terms of the other part on the machine learning part, it's basically multispectral images that we collect. So it's sort of a dual track kind of approach, where the problem modeling takes care of all these variables that you just mentioned. But on the other side, for the machine learning process, we're basically getting the information from the multispectral images.
Right, because I saw your little plane, your little drone with which presumably has a camera on it.
Right. So we mount the drone. We mount the multispectral camera on it, and we fly over these 10 plots throughout the growing cycle. So we have about 4 or 5 flights throughout the 4-month growing cycle, and we generate not only NDVI but various vegetation index that we think relate to yield, and so we could input that multiple variable vegetation indices into the machine learning program, and try to figure out which one has real effect on the results, which one does not, and that's what we're experimenting with.
But yeah, so what I'm trying to get into my head, I think, is that the multispectral imaging alone is probably not sufficient to predict crop yield. I would have thought that you would need all these other parameters.
I think those parameters, what we try with the machine learning is also to input like the planting dates and the dates and the number of days where the images are being taken. And we had initial results that shows that if we put the number of days after planting into the one of the variables that we put on include in the machine learning process, the accuracy does increase. So we're experimenting with different kinds of variables to be included in the machine learning process.
Okay, I guess the proof is ultimately whether you get a good model out of it, but I'm just thinking that there will be so many variables that you will need a machine learning model and feed it all the other stuff as well with it.
Yes.
Is your data set an outcome of your project, or is it just a model?
It's the data set that we have is going to be an input to the machine learning process, because
yes, but is it an outcome of your project as well?
Yeah, the outcome would be the predicted yield. And what we do is that since these fields are being harvested, we know the exact amount of tons per acre, or the exact yield of each plot or each miniature plot. And so what we train the machine is basically to get all these inputs, all the vegetation indices, and to come out with the most accurate match of the measured results.
Yeah, because I'm thinking that some farmers may not have access to the camera, to the drone with the multispectral imaging, and may want to have models trained just on the data, on the weather data, and use that to give perhaps a less accurate prediction of the yield, but at least they will have some prediction of the yield. And perhaps you can even do feed that into more sophisticated models where you can look at a kind of like a digital twin, where you have saying, if we get this kind of weather in the coming season, then I will lose 20% of my yield or something. So provide, I was thinking you can increase the impact by not just looking at the multispectral imaging for your machine learning, and also by making the data set available for other people to build models on.
The data would be available for other scientists to.
Okay, I mean, feel free to disagree with me. I'm just thinking out loud, but I think
I think in UKRI Remit, we have agreed for the open data access. So yeah, it's a requirement from the funder as well, that the data that has been collected for this for any of the research funded through UKRI is available through open access. So we are hoping that we should be able to keep up with the requirements of the funder.
I sort of imagine it leading into like something like a digital twin of a field, where you can feed some climate data into it and then try and see how that affects the crops as well.
Yeah, I mean, I think it would be also helpful to have some sort of maybe a standardized protocol for such data collection, which can feed into machine learning models or AI models. Yeah, so if we were to start collecting data from scratch in place X, and use a similar sort of model, how would we do that? So maybe think in that sort of lines. I think we can have some follow-ups on developing some sort of protocols for data collection for such models, ML models. I think that would be a very good output of the project.
Thank you for the input.
Yeah, and just to be clear, I'm not criticizing your work. I'm just thinking that we can build stuff on it. I'm just getting excited here.
It's very helpful to get different views.
Okay, moving ahead. Then we have next one from University of Sheffield, Dr. Po Yang, and he would be presenting on AI AMMS, which is AI coupled with the aerial eye imaging and mobile sensing. So over to you, Cindy. And Peter would be the lead reviewer on this one.
Hello, everyone. We'd like to present our research, AI coupled with aerial imaging and mobile sensing. The food challenge our group is addressing is one of the most globally concerning problems: yield losses. Insect pests cause an average yield losses of 15 to 20% and may reach a maximum of 80%. However, pesticides are often applied with an inference basis rather than a prescriptive basis. In order to enable sustainable farming, more measures have to be proposed. In our research, In order to detect and quantificate weed diseases in multi-scale fields, we proposed a deep learning-based image analysis model for extracting discriminative features from UAV images. In addition, broad learning techniques were applied for fusing UAV feature and multimodal data to improve accuracy. At last, we explores how this can be combined with accepted threshold level to produce an informative multi-level pest and diseases management output. Regarding data collection, so far we have labeled pest datasets, including over 500,000 images, and have manually collected 3,000 mobile pest images in the UK. In this project, STFC deployed a lightweight hyperspectral imaging system, capturing images of over 41 wavelengths, which greatly contributed to the development of our pest disease detection model. Our project has made a wide range of impacts. In the industrial community, we disseminated our research with UK companies such as ADAS and Multistec, built partnership with end users and stakeholders, etc. Regarding commercial applications, we've developed an AI mobile intelligence for climate-smart pest management and an image recognition application for real-time nematodes detection. We're collaborating with 4 UK farms for data collection and aim to provide training and guidance to enable sustainable cultivation. Our research also aligns with net zero emission target and low-carbon agricultural incentive policies. Upon completion of this research, we plan to present the research results at major international conferences and journals, and organize special session on precision agriculture in IEEE iThings 2023. This concludes our presentation. Thank you for listening.
Thanks, Boyang and Melina. Now over to Peter.
Yeah, I'm here.
Yes, this is all looking very interesting. One specific question to start with. The spreadsheet that I saw said that you didn't expect to complete the work by August. Do you have an expected completion date?
Yeah, I think the main thing is about the seasons. We plan to have a data connection in May, early May in Austria. So we should be able to complete it by the end of August. Yeah.
Okay, very good. I noticed that you've got quite a lot of follow-on funding, which is splendid. Is that contingent on having got the work completed by a certain date?
You mean the ongoing projects or we had one new project just start from officially 1st April. It's 18 months until the end of next year. It's the Innovate UK project, half million, and it's for the past, collaborating with the others. At the same time, we have another project for the fertilizer management until the end of April. I think that's 3.5-year project. Right. So we have some few projects in parallel, but I think these two main projects will provide the resources to us and all the farmers, because we working quite close with the farmers, and especially in these 2 months, we visited the farms every week nearly. Yeah.
Okay. You talked about publishing papers, which is, of course, the standard output of a research activity. But how do you plan to make sure that this is adopted on a wide scale? So same question as I asked someone earlier about plans for commercializing it so that it will be widely available.
You mean the quality of the publications or about the wide impact for the end users?
I mean, as a farmer, how will I know that this even exists, and why should I think it's a good thing for me to use?
Yeah, I think
the research papers.
Yeah. I think here I want to clarify. I think for our end users, not only just the farmers. The 3 types of end user. One is about the farmer managers. Yeah. Second is about the agribusiness, because if we see the commercial opportunities, we won't be able to get paid from the farmers. Sure, so if we make it very successful, we already have apps particularly provide for the agribusiness and also the farmers. So this is actually, they will provide free to them to use. But in collaborating with the others, they would like to make a license for that. So for the agribusiness. So that is actually, we have where we already built up the connections within our community. But the main issue is like we didn't push up about the dissemination in this stage, because commercialize the products require a lot of resources to making the product very stable. Yes. We don't want to like just within 1 week they use that, but then they find out, oh, some bugs, they will give up 1 week. Yeah. And in the meantime, we noticed our competitors in the market. Yeah, in the past, for the mobile apps, most of them actually do the data connections and the label, but they don't do too much AI and also decision-making tools. We understand this is very difficult, because if you go into the field, every people farms, you couldn't ask them to follow some specific guideline. They will just take the pictures. So for this project, I think we are more or less as a feasibility study. So we try to combine the models from our mobile apps and also the data actually in line with the UAV image data, and then try to see if we can provide some more solid solutions for the farmer managers. Especially we got some feedback from the well-caught companies. They're very interested in the drones. The main problem is actually they have to using the spraying applications to their farms. So they using helicopter to that. If we can actually be able to do the identify which areas, they will save a lot of money to them. So we see this is also some commercialized opportunities, not just only provided the application to the individual farms.
Yeah, so it just occurred to me, you said that there are apps out there already, but that they will have not as good information as you've got. Fine. So the obvious thing to do is to have some new apps which are much better than the old ones, or maybe work with the people who have got those apps to say, hey, we can help you improve what you've currently got.
Yeah, that's absolutely good questions. We got actually in contact with I think Actuaric apps. They are also actually leading, and they're interested in that. But they also have have a similar problem, is that they have limited resources. Right. So the strategies, if you see the AI models, first thing you need to build up the established data set. But that's actually require a lot of resources. Yeah. And so now the apps more or less they provide this to get sufficient data as much as possible. After that, they want to collaborate about. But our work is more specified into the wheat pass with this. They are more general. So we try to actually compromise, but we are competitors, but we also want to find some like meaningful work. So still, this is the best way to work on. And also in terms of the final decision model, I think it's not only just AI, because nowadays the ChatGPT is actually quite popular. So we need to foresee the future, because if we see our apps is kind of assistant to the farmers. So we actually rely on some expert decision systems. So we build up the rules by the experts' knowledges. But if in some case, if the ChatGPT will be able to provide some meaningful rules or results, then we need to consider how to integrate in our systems. Yeah. So that is also.
I certainly don't have any magic answers here. I'm just hoping to ask useful questions.
No problem. Yeah.
Okay, those were my useful questions.
Okay, thanks, Peter. Just one additional comment. So let's say if I'm a farmer and I have people doing quite a lot of work on pest and fertilizers, and then somebody doing on carbon, several different apps. But how would, let's say, SFN make my life easy or easier? Can we have a platform where we can integrate several different outputs or the apps or the research that we are hoping to make the life of a farmer better? Can we offer that as a SFN group to farmer or farmer community? I see Rachel putting a thumbs up. Thanks, Rachel.
Yes, thank you for the questions. I think technically we definitely will be able to do that, because for us we actually provide the platform which we have submitted some codes, and they should actually be able to connect with the multiple different kind of apps. But the realistically, there were issues because when we deploy to the different user from different countries, they face in different scenarios. For instance, in Africa, in China, the passive density completely different, the types are different. So whether we want to build, say, the answer is that we build up the communities and the platform, but whether it can be made useful, willing to the end users, there is a trade of that. Yeah, we need to balance with that. So this is actually what we see the problem. Yeah.
And Po, if I may, just to say that they will all, irrespective of their geographical location, need to keep records. So if this is a way for them to get the advice, gather the data, but also use it as a record device to then hold as the evidence. It's two sides of the same coin, I know, but that is something they struggle with and then struggle to present in a format that different customers, different regulators want. If they have their own data set that they can then push a button and it's formatted for government, push a button and it's formatted for customer, that is a huge benefit for them.
Yeah. I think thank you, Richard. That's a good. We in another project we do the fertilize one. We actually provide this kind of functions. So it's more like the message driven. So we got to feed the record and deliver to the farmers, and then the farmer, once they complete the practice, they send it back. So we have those things. But that is specific for the fertilizer. If you want to build up a complete comprehensive kind of a platform, it needs more effort. Yeah, but we would think about this is a very good suggestions. Yeah, take up.
Yeah, even if we don't get up to the platform level, can we get up to a level that we can have, again, repeatedly I'm saying about the standardized protocols for data collection, because this is something that is missing in different farming communities. So if your if your model, and we have just heard from Vivet Wong as well, and others, if we can come up together as like, these could be the data collection protocols for the farming communities, or like, so let's say in the developing countries, the people who would be mostly collecting the data, from my experience, it would be mostly the NGOs or the different companies. So we can provide some sort of like, protocols and training materials for them, so that even if it is the platform or the ML is not ready for them, at least we have somewhere to start and build on things, because at the moment there are like random data collection. And when it comes to ML and AI, they are very far off, because the people do end up cleaning all the data sets, and then we find out that, it's not much use, all those data being collected. So can we, as a community, a research community, offer some sort of materials and the training materials and the standard protocols to those communities who can use them? Yeah. So this is something that I would be very interested in building this up with different projects that has been funded in the similar sort of theme of remote sensing and AI for sustainable agriculture and soils, if that is okay with everyone.
Yeah, I think we will present in the summer conference. Yeah.
Okay, super. Thanks, Po-Yang and the team. Right, moving on to the next one. Then we have developing new testing methodology for honey authentication, presented by Dr. Maria Nithavi from Cranfield University. This has been co-funded by Food Standards Agency, and lead reviewer for this is Rachel. Over to you, Maria and Cindy.
Our project is co-funded by the FSA, and it aims at developing a new testing methodology for honey authentication. Honey is a valuable commodity, appreciated for its flavor and nutritional qualities. However, it is also one of the products most at risk of adulteration, the main form of which is mixing honey with sugar syrups from plant sources, such as sugarcane, maize, rice, and sugar beet. Currently, there is no single method for honey authenticity, with C3 sugars in particular going undetected. As a result of those limitations, policymakers recognize the need to develop alternative methodologies. The methodology we propose is twofold. The first objective is to develop a DNA barcoding method for sugar syrup detection. This technology uses a short domain of DNA from a specific gene to achieve species identification and has shown great promise in identifying honey botanical origin. The same principle will be applied for sugar syrups to develop a novel methodology. The second objective is to investigate the suitability of spatial offset Raman spectroscopy to identify possible adulteration in honey. This technology is available from the STFC partners and has already shown encouraging results during our previous scoping project. The two methods could act complementary to develop a decision support tool for exogenous sugar detection. To test the efficacy of both methods, we purchased a collection of different honey types from across the UK directly from the producers. In addition, we acquired the selection of sugar syrups from different plant sources and tested different DNA extraction methods to define the best. We finally sourced plant material for each of the plant species studied to use as positive control. We germinated the seeds and used the seedlings to extract plant DNA. The next step was to design DNA markers by using suitable bioinformatics software and genomic databases. The design markers were tested with PCR to determine their specificity. Here we present some preliminary results with the rice marker we designed. The results correspond to normalized amplification with rice plant material set at 100%. Most of the rice syrups showed good amplification, while corn and sugar beet plant material showed no amplification, indicating the marker was also species-specific. Although some corn and unknown syrups showed some background amplification, we could set a minimum threshold to avoid false positives. To maximize our project's impact, we work with the FSA and DEFRA to provide regular progress updates, and we engage closely with the Bee Farmers Association, who support us with sample collection and results dissemination. We will also present our work in the upcoming European Symposium on Food Safety. In the future, we will apply for further funding to expand the scope of our project with the aim to develop an in-house honey authenticity database. Thank you very much.
Thanks, Maria. And Rachel, over to you.
Thanks, Maria. First of all, I look forward to seeing you in Aberdeen. I'll be there. I'm looking forward to that conference, so we might make sure we say hi. This is really interesting and very needed. I had a question, however, that the focus seemed to be on adulteration with different types of sugar sources. But a lot of honey authenticity issues also come from dilution with different types of honey. So something might be labeled as blossom honey or ling heather honey, but actually it's baker's honey that's maybe had a little bit of a flavoring added to it, and maybe a little bit of ling honey, enough to just give a flavor so that the person eating it can't tell the difference. You've not included that within the scope. Is that because there was a very specific scope for adulteration with other sugar sources, and you've not been asked to consider that aspect of adulteration?
Yeah, that's a very good question. So a few years ago, we had a scoping project, which mainly considered botanical origin authentication in honey. So we have followed up on this project, and we have a BPSRC DTP 4-year project, which is considering both aspects. So we're focusing on heather honey in the UK because it's the most famous and the main monofloral honey in the UK. So we're using similar tools, and we have managed to create, again, DNA markers for assessing botanical origin for heather honey. For this particular project, for the proof of concept project, the FSA was specifically interested in exogenous sugar adulteration. So we tailored the scope for this particular project to reflect this. So yeah, because They're currently in the process of collecting samples, creating an UK-based database with other methods, but they're also interested in assessing our methods and seeing if they can be added. So yeah, we're in the short answer is we're considering both, but for this specific project, it's mainly sugar.
And so I suppose there is an opportunity, isn't there, to look at the pollen contamination that will always be there in the honey, to use that as a marker, because you can get, obviously with heather honey, but if you're looking at, I don't know, I'm just looking at the legislation, Banksia menz, and I can never say Menziesii, and the false acacia honey, there will be pollen contamination that can also help. And I didn't know whether you were considering microscopy and considering looking for the speciation of the source for other types of honey. Particularly, it's almost looking at the definitions of honey. So I'm a food regulatory professional, and I would start with the definitions of honey and say, is it honey or not? And part of that would be the source, the pollen, the botanical origin, and then does the sugar profile look like it's coming from different sugars? So you're at the second question, but it's almost like asking for directions. I wouldn't have perhaps started there, but I know FSA have already done a lot of thinking, so that's probably why they're asking for the focus in that place. I don't know if there's opportunity to look at those aspects or whether that's too much scope creep on your project as it stands.
So for this particular project, again, we're not looking into it, but our other projects, we are considering speciation, and we're looking into DNA metabarcoding. So instead of employing microscopy, which we are using as a control tool, since it's the it's the standard method, we're using the microscopy to compare against the new sequencing methods that we're developing. So we have started now looking into sequencing the honey and creating a list of all the plant species from that pollen exists within the honey. And we're also trying to see if we can quantify. So it might be a honey that is predominantly heather, let's say, but would we say this is monofloral or multifloral? And so
yeah, that's the piece, isn't it? Because then it's that progression from, is it honey? Is it this kind of honey? Is it this kind of honey from the origin? And then you need the progression of the testing, almost decision tree. Because if it's not,
if I may add, we can also connect that and relate that to geographical origin, because the specific flora in a geographical area is indicative of the geographical origin of the honey, and we can also see whether it has been diluted, as you mentioned earlier, with cheaper types of honey that come from a different part of the world.
It would be useful for when you do the output report to perhaps show the stakeholders from an impact point of view where this analysis would fit in the decision tree of what is it, and perhaps lay that out in your report to say, is it honey, yes or no? Is it honey of this type? Is it honey of this type from this origin? And then people can see where they would use the different methodologies that you've been creating and the ones that already exist. Picking up on Jens's question, would you replace the DNA markers, or would this be augmenting the DNA marker methods? And it might mean that if you do the Raman spectroscopy and find out that it's already adulterated with sugars from another source, why waste the cost and time at doing the DNA? Because it's irrelevant, it's not honey, throw it away. It doesn't belong in the market.
Yeah, the way we see it in the FSA is that because the Raman spectroscopy is non-invasive, it's rapid method.
Yes, very useful.
Faster and cheaper, it can be used as a screening method.
Yeah.
And then if something arises, like a suspected adulteration case arises, then we can also use the DNA method.
And that's so helpful because you could use it then at border control, and you could use it at incoming raw materials in a factory on a handheld, and all they care about is it what it says it is, yes or no? and then
exactly, yeah.
get rid of it.
The only issue with the source is that currently we have limited resources, so we cannot test every type of honey that exists in the market in the UK, but hopefully like in a follow-up project, but this is our goal, that we can create this database and we have the fingerprint of every type of honey that is currently on sale, and we can use this to do the screening method, definitely.
Excellent. That's so helpful, Maria, especially the library of the fingerprints, because that's what stops a lot of people using this technology.
Yeah.
Yeah, thanks, Rachel. I think, Maria, because in the conference there would be other funders as well. So I would suggest that, the next steps, when Rachel said that, it can be used as like a handheld sort of detection tools in the borders and during the exports and things. So highlighting those, like how impactful these libraries would be in future, should there be more potential funding coming this way, then that would definitely attract some of the attention from the funders. So yeah, make sure that
the project.
Yeah, and this goes for everyone. Like your stopping, your final slide should be that what this project could achieve as like a bigger picture. Should there be more funding? Yeah, so goes for everyone. Thanks. Right, so moving ahead, I think we're doing good with timing. We have two more projects to go through. And thank you for those last two projects to patiently wait until your turn. So thank you very much. Shuyang Li, Dr. Shuyang Li from University of Sheffield, who would be soon moving to University of Birmingham. And she would be presenting on building a food waste tracker for responsible consumption and sustainability enhancement. And this lead reviewer for this one is Jens. So over to you, Shuyang. And Cindy.
Hello everyone, it's my great pleasure to introduce our project, Building a Food Waste Tracker for Responsible Consumption and Sustainability Enhancement. The challenge we're addressing here is food waste in the UK. So the food waste is a very significant problem in the UK. You can see a few figures listed here. To address these issues, REP placed resource efficiency as the primary solution. To achieve it, reducing waste should be taken rapidly and at scale. In this project, we aim to achieve the rapid and at scale by restructuring a food waste system. So our project builds and extends the previous work from SandPit 2020, where a food tracking application was initially developed. In this project, we aim to further enable algorithm-driven intervention to build simultaneous feedback to food retailers and producers, as well as to further engage and educate customers. To achieve it, our methodology is divided into 3 phases. In the first stage, we integrate more database into our existing application, as well as did further improvements for different functions in the application. In the second stage, we collect and accumulate data from users, and we also use eye tracking machine to further improve the user engagement interface. And in the third stage, where the STFC capacity will be mainly involved, is to analyze the data from the app to build algorithm to place intervention on reducing food waste, as well as predicting future waste amount and behavior. Now for impact, we're already engaging and impacting on local food retailers to help them better understand local food waste data and amend their supply decisions accordingly. We also engage with local food producers, currently working with 2 farms in Edinburgh. They can benefit from the data and results, as well as individual households and consumers that they can benefit by tracking their waste data, nutrition consumption data, as well as adopting the AI-driven interventions. Our commercialization are 2 aspects. So the first is the improved version of the food waste tracker can be applied to a larger scale of customers. And second, the algorithm developed can also be used for wider collaboration to monitor the waste in the food system. Our plan afterwards include project bidding for scalable reducing food waste intervention or sustainable food supply chain, as well as academic publications. Thank you.
Thanks, Yuan. Right. We have Jens as the lead reviewer. Jens, over to you.
Okay, thank you. So I probably missed it, or maybe I'm just being slow. So who is actually interacting with this system, Shuyang? Is it the consumer? Is it a restaurant? Is it the food producer? Is it the market, like the supermarket, or who's using it?
Yeah, thanks, Jens. No, you didn't miss it. I think I probably didn't clarify that enough in the presentation. So at the moment, we're collecting data mostly from individual households as the consumer, mainly the users for the app. But by the end of the data collection, once we have the algorithm built, we want to promote it to the food local retailers, for example, the local grocery stores, and also the farmers, so they can see the analytical results from the end users.
Right. And so as an end user, I might waste food because it's not consumable, like it's a part of an onion that I've chopped off or something, or because it's past its sell-by date, or because it smells bad, or because of I don't know, maybe I've just bought too much because I got tempted by the buy one, get one free in the supermarket. So are you tracking the reason why the food gets wasted?
No, we're not tracking the reasons. We're mainly tracking what are the amount of food and type of food that goes to wasted. And we're also tracking the date. Is it before expiry date, or is it after how long, how many days after expiry date it goes to wasted? The reasons will be a bit difficult to track. Use the app. We need the only data we're capturing are mainly the amount of food and the type of food.
Okay. So, but does that include stuff that I bought that is just basically not edible, like when I peel the onion, then the peels will not be edible, like only the onion will be edible.
Oh, no, in that case, the user would not type the onion, the peeling of the onion as waste food. So what initially does is when, as a user, when they do shopping from supermarket or they plan their meal, they record all the food they buy. So in the app, we have a place for inventory. So they record all the information there. And then they can choose from the inventory, for example, if they buy a bag of 5 apples, and then after a week, 2 goes to wasted, they choose from the inventory, mark those 2 as food waste and the 3 as eaten.
Okay, so what I'm kind of fishing for with my questions is whether there are things that they could do with that waste to prevent it being wasted, like a circular supply chain, or they could give it to someone else, or it could. So normally we put it into the bio waste basket in the kitchen, right? But possibly they could give it to someone else if the apple is still good enough that somebody else could eat it.
Yeah, that's a good point. Actually, we have a function for gifting the food in the app, but the idea is really when we start accumulating those data, for example, a user start using it for, let's say, 3-4 weeks, they can see the analysis of all the food waste behavior they have been, for example, certain type of food they continuously throw away, so that raise their awareness about probably start buying less of this amount of food, or start gifting it to, let's say, either the local food bank or charities. And also, we're trying to do this in a small scale at this moment. So mainly we're focusing on recording the food waste from Sheffield, a particular S10 area of Sheffield. So we want to collaborate with some local grocery stores. At the moment, we have 2 on board. So we want to feedback them about, look, this is this area, the amount of food that people tend to waste. And for a grocery store, probably want to take some measurement, or the analysis of the food waste probably can impact on your decision making about what type of food you want to provide.
Okay. So what does the AI actually do? The AI-driven intervention, you called it.
Yeah, so that will come in the, so at the moment we're still in stage 2 of collecting all the food waste data. The AI will, after we have at least 5 weeks of individual buying and waste data, then the AI will predict what are the waste behavior, what is the waste pattern. So it will be useful to feedback the individual users. And also we can feedback to the local grocery stores about it.
Okay, so you don't actually use demographics for that, you just do it by individual user.
Yeah, well, it's actually for some ethical reasons, we didn't get the ethical approval to record geographical data at the moment. It's a proof of concept project. So, but we try to prove this idea of recording shopping, recording waste, having the algorithm there to feedback individual users and feedback local grocery stores. So the whole idea, if it works, later on we want to add geographical location information to the app so that when we have other grocery stores, they know what other users in this location are mainly wasting about.
Okay, but conversely, the food that is likely to be wasted might be the fresh fruit that I buy, whereas the unhealthy snacks that I put on my shelf will last forever.
Yeah.
So you might argue that I waste a lot of my food and I should buy less fruit because it's perishable. And buy more snacks because they're not perishable.
Yeah, that's true. That's why we also have the nutrition information there in the app. So when the user records their food purchase, their food consumption and food waste, they not only have a list of the food waste data, they also have a list of the nutrition data based on what they record in the app. So we provide them analysis of the basic nutrition they have eaten and they throw away. So just kind of raise their awareness of it.
Okay, yeah, thank you very much.
Thank you, Jens.
Sorry, just out of interest, Shuyang. So, what help in decision making, or what kind of decision making help are you offering to retailers or the local retailers? So, for example, if my local retailer knows, okay, I waste maybe, buy 2 packs of strawberries and waste 1 pack of strawberries. So would they ration me when I go to buy strawberries next time? What's the intention? What's the output?
Yeah, that's a very good question. So now we're actually in contact with one local store just around Crooks, just called Just Natural. So there are two aspects we can actually provide feedback to them. The first is mainly providing them, look, these are the type of food, for example, fresh milk, or let's say fresh vegetables, a type of vegetable tends to be thrown away in this local area, just let's say this residential area. So they probably want to either adjust their measurement when the amount of food they provide in store. And that is one, but from the local grocers, from the store's perspective, they probably wouldn't want to do it because they want to sell food as many as possible. And the second one is for many local stores nowadays, they're collaborating with charities and food banks. The one in Sheffield, the 2 we're talking with, they all collaborate with local food banks and charities, so they can put a sign there. For example, if we tell them these are the amount of food locally tend to go to waste, they can start collecting those type of food and signposting the customer. Next time when they go shop, they can actually gift those foods, let's say 1 or 2 days before expiry date. Instead of throwing them away, they can actually donate them into the local bank.
Okay. Yeah, I'm still struggling to see how that would work practically, because normally customers who would throw away, let's say, fresh produce and things, they might just straight away throw away after the use by date. And if you do have the tinned and the canned products, then yeah, maybe it might work. But yeah, it would be interesting to see. It would be interesting to find out how the things have worked out for both the consumer end and the retail side.
Yeah, it is actually a very good question, and we're still exploring because now we're still in stage 2 of collecting all the data. I guess once we have them, we'll have more word with those grocery stores and see how we can better help them. The above 2 aspects are what we have been discussing at this
moment. Because I again see a couple of apps for the retail and the consumer, and one was related to the carbon calculator. One is related to the and it's quite linked. And again, can we think of some way to come up with something jointly through these proof of concept projects? Can we link them together so that again for the consumers it doesn't become a hassle of having again too many apps, and we can offer that as like one platform. Yes, Rachel.
I was going to just echo that, but also perhaps think about budgeting. So this is a cost of living scenario as well as an environmental resilience scenario. So there would be opportunity and benefit to the consumer to use it. It helps them know what they're wasting in their personal finances as well as what they're wasting in terms of food waste. And maybe also link it to some of the triggers where it says, oh, you threw away this last week. You could have used it for, and give them tips and advice on how to utilize and be less wasteful with particular types of food that's based on their personal household data, which then takes into account ethnicity, diet requirements, diet preference, and so on. So I'm gluten-free, so I don't buy bread that goes off quite so quickly because I don't buy bread that often. So it would be, as a household, you've got to give them a benefit for taking the time to collect their own data, unless you're collecting this data solely, and this is my confusion with it, solely for the benefit of the retailer to know what to put on their shelves, so they know what the consumers locally are buying, which is also a benefit. So they're not wasting food that then goes off before they can sell it. So there's an opportunity there for both those stakeholders, but I wasn't clear that it was a strong enough message about the benefits to either of those groups.
Yeah, I think the financial benefit would definitely work for consumers. Like if we are wasting this much of amount of food, we are also wasting this much of amount of money, as well as carbon. If you could add to that.
Yeah, that's a very good point, Rachel. Thanks for mentioning it. Actually, in our team, we're discussing either to add this function. The problem is we struggle to find a database that containing all the UK average food price and link what they throw away to the price, so we can do the calculation. Especially nowadays, the food price keep changing. But it is a very good point. We are seeking if there is a database available, so it's not difficult to link that to the food waste data, yeah, but it's also useful to think about the triggers and advice based on, let's say, in the end, once we have the algorithms done, can we actually also provide some advice, tailored advice to individual users? These are the food you wasted, and here's the advice we provide to help you to avoid those wastes.
It might be they don't know what to do with, 3 carrots or 2. Do you know what I mean? They might not. They might not know. But the thing about the pricing, there might be people, Sunal at the conference, who can give direction about where to find that kind of pricing. It's there, but yeah, it's in the supermarket's hands.
I suspect providing the information at the right time could be crucial for this, because to take one extreme example, you've been out, you've done your shopping, you bought twice as many strawberries as you needed, and you then sent an email saying, based on historical data, it looks like you bought too many strawberries, and just feel guilty and forget about it. But if when you're actually buying something, you've got an app and it says, do you realize that the last 2 times that you bought strawberries, you only used half of them? Maybe you only need 1. That could have an immediate impact.
That's a really great idea, Peter, because lots of people, for example, don't know you can freeze hard cheese. So if, for example, the supermarket say, oh, we've done a swap and we're going to send you half a kilo of cheddar, and you're like, I only needed 100 grams, then you can freeze it. And the texture is not great, but it's fabulous for cooking. So again, that would be really helpful for people to go, oh, I've got too much of this, what could I do with it? And it's the same information that you would have at the other end. So yeah, great suggestion.
Yeah, thanks, Peter. Thanks, Rachel. There is another project called Nudge Plus, which is, of course, not funded through SFN, but it has been funded through other organizations. I think it might be worth checking with them. They do put up some sort of nudges for consumer behavior changes. So it might be useful to see if we could also, develop some sort of nudges for sustainable consumer behavior.
Yeah, that's
great. Thanks, Xiang. Okay, now we are moving to our last presentation. Thanks so much, Ruben, for waiting. So yeah, we are looking into now evaluating influence of moisture in controlling release of nutrients in novel green fertilizer using neutron imaging and Meonic X-rays, and the lead reviewer for this would be Peter. Ruben, over to you.
Hi, I'm Ruben Sakrabani from Cranfield University, and it's a pleasure to present at this proof of concept impact forum on evaluating influence of moisture in controlling release of nutrients in novel green fertilizers using neutron imaging and Meonic X-rays. I'm pleased to acknowledge the contribution of co-investigators at STFC, Dr. Genevieve Burka and Dr. Hadrian Hillier. The food challenge that we're trying to address here is looking at food security, in particular looking at the role of fertilizers that is so critical at the moment to meet food demand with growing prices due to the pandemic and also changing weather patterns. So the chemical fertilizer is high in its energy consumption for its production. So it's really key that we look for alternatives. And this is where it's a pleasure to work with an organization that's providing this technology to capture CO2 into food waste and converting it into a fertilizer. So this is also very timely to look at policy development such as Net Zero Carbon Agriculture Bill and the DEFRA 25-year plan. But one of the challenges in using these sort of novel fertilizers is the traceability. And that's where the technology and the facilities at STFC is very appropriate. So the aim of this project is to look at how we can use the STFC facilities such as the Neutron and also MON to look in particular the impact on moisture content and how it is influencing the quality of these novel green fertilizers. So we will look at the variation in the moisture content and look at how the physical integrity of these pellets would be affected using the neutron computer tomography. And we will also look at the use of the MUON to look at the chemical composition of these pellets. And this proof of concept is building on a previous feasibility study that involved using neutron and also Raman spectroscopy. So for the neutron, we were able to carry out the feasibility study, and we were able to show that it actually is feasible. And the video here shows how the cross-section of the pellets as you are cutting across to look at the solid part, which is expressed in the gray color, and also any voids, which, in general, you can see that the pellet is quite uniformly packed. But it's not necessarily the case all throughout. And I'm just going to repeat this video again to show that the variation in these packing density is actually very variable, and that's some of the things that we try to evaluate in this project. The next slide just shows the cross-section using the software that's used to gather all this information to create the video that you've just seen. And this just shows the impact of moisture on how it's really vital to see how the moisture actually influences the integrity of the pellets. You can see due to the swelling of the pellets, you can see compared to a dry pellet. And this is really key because it will influence the storage quality in the barn, and also how easily it can be spread using the spreader, as you can see in the bottom right hand corner of the slide. So in the proof of concept, we will build a specific chamber that we will place the pellet in this chamber, and we will introduce aerosols, moisture, water vapor aerosols to saturate this cabinet or this chamber, which then will eventually also saturate the pellet, and then we will then bombard it with a neutron to look at these impact on the structural integrity. What are the next impacts? We are fortunate that we have already managed to get some beam time, as shown in the slide, for 5 days, but we are also aiming to get the beam time for neutron, and we're also trying to finalize a paper from the previous feasibility study, and we're hoping that this is really going to be instrumental in giving information about the detailed mechanistics of the influence of moisture on the pellet integrity, and also try and use this fundamental work to see how this is really vital to see the importance of using such technologies to get more understanding on these new fertilizers. Thank you.
Thanks, Ruben. And now we have Peter to have follow-on questions.
Yes, thanks, Ruben. I can see from the information that was provided that you've had some delays in the work along the way, but for in terms of assessing impact, I just want to assume that everything actually will go fine in the end, because that's a separate issue, really. So you wrote that the impact is to inform farmers. How do you intend to go about ensuring that they actually make use of the information that you're providing? Because you can tell people all sorts of things, and they don't always pay attention to it.
Yeah, that's a very good question. I certainly was not envisaging that farmers will go zapping their fertilizers with muons and neutrons, because that's not
no, of course not.
But the key message from a practical end is to see, because the pellets are of organic nature, so we are already they are stored in barns under normal barn conditions, so subject to all the weather elements. So the level of the moisture absorption will inform the farmers on how they can store these materials. So one of the work that we're doing already, we find that when you store these fertilizers in large bags and you stack them, because of they tend to kind of disintegrate with time, they tend to cake. So you can imagine all these pellets caking and forming big lumps. And when Mr. Farmer comes in the next season and applies the fertilizer, he's not going to apply a pellet, he's going to apply a lump or lumps of fertilizers. So the kind of the practical implication of our work is to see what is the optimal moisture regime, what is the conditions when the farmer would have to make sure that he's actually taking some care in terms of providing an environment that will be conducive. He can't, or she can't probably can do some insulation. Heating obviously is an option because there's energy implications. So that level of practical end is what we will doing. We will hopefully provide an impact. And also one other practical implication is also when the spreader spreads the pellet, if it is actually not dry, then the spreading bandwidth or the trajectory of the flight of those pellets would be much reduced. And that would also influence in a homogeneous spread of nutrients. So these are the practical ends to the farmer.
Right. Is it possible to say yet whether providing the appropriate advice to a farmer is adequate? And I'm thinking of, this is how you should store it. If you do it carefully, it'll be fine. or is it necessary for the farmer to monitor the moisture content?
I don't think it's necessary to monitor the moisture content as yet. I think if we know what is the maximum capacity for the absorption potential, you know, where the pellet doesn't buckle, then I think the farmer can, you know, maybe spread out, you know, don't have to monitor every month or every season, you know, maybe it could be a bit more, because any level of monitoring would also incur cost, I would imagine. And we obviously want to minimize that, because that will then shy them away from using this alternative material.
Suppose if they grow as they get absorb moisture, then you can just check if they've grown. Like if you had these 5, 10, and 15% moisture, right? So if you could actually use the growth of the pellet to infer how much moisture they've had, then, or some other simple test, then maybe that's something they could do.
Yeah, I mean, we partly will do that in the chamber technique that I mentioned to you, because the chamber, the pellet will be placed there, and then we will diffuse it with water aerosols. So we will know the point when you know the absorption capacity is there. Yeah.
But you may get, so you learn something from the from your experiments, but eventually you can infer maybe a simple test that the farmer can do just to check whether how much moisture is in there.
Yeah.
Like weigh them or try and break them or something that they can do.
Or I was thinking, if they're stored in a jar, I'm not sure if there would be, then you don't want to be going and measuring the size of every pellet. But if the contents of the jar was raised up the jar because things you might be able to measure it that way. I mean, ultimately, this all comes back to what's the most cost-effective thing for the farmer to do.
Yeah, absolutely. Yeah.
So that information needs to be provided. Yeah. Do this and you'll save money. There's no point going over the top.
Yeah.
That's very good.
Okay, that's it from me.
Okay, sort of one. Yeah. Okay, that's all good. I'm very pleased to see the progress you all have made so far, and thank you for sticking for 2 hours 17 minutes so far. Right, I think there would be different follow-ups where I would definitely like some joint outputs coming from different projects where there are a lot of synergies and overlap, and we can together come up with some sort of either that would be in form of like, you know, protocols or standardizing protocols where the different communities can use, or either that can be developing a common sort of platform with different app functions that either the consumers are able to use or the farmers are able to use, so that we are not populating them or making their life difficult. We want to make it easier and user friendly. So we are hoping that, like, you know, over the next few weeks, I would be clubbing people together and asking for a few follow-up meetings to see how we could collaboratively bring those findings together, whether it would be in this phase or whether we would need that to be extended through the other bigger grant projects. We can have a discussion and follow-up sort of discussions of that. Okay. Any other comments from any one of you? No. Okay. Then thank you everyone for your time and input and your enthusiasm for doing this project. And thank you so much, Peter. I think Rachel had to go. Peter and Jens, for your time, for reviewing these projects. Your input are definitely very valuable for them. And we hope to keep you engaged in how these projects are developing and in the potential impact that these projects are going to achieve. Yeah. Okay, so thank you everyone. We finished around 40 minutes before our intended time. So yeah. Enjoy the rest of the day and happy Easter vacation to every one of you, and see you all at the conference.